In order for us to plot vectors like this, after having calculated their cosine similarity, we need to talk about the polar coordinate system. So let's first talk about the first prerequisite. Okay, this is going to be about cosine similarities or similarity and the polar coordinate system. And this will be a foundation for other topics that we'll be covering in this course, but later on even for differential equations. Why differential equations? Because the prerequisite for differential equations, in particular partial differential equations, is complex analysis. And you know, in complex analysis, we have these imaginary numbers. And so we use the polar coordinate system extensively. Okay. Anyway, let's create a new section here called cosine similarity. And the formula is this. Cosine similarity. You would get the angle theta. And that's how you'll know how far these words are apart from each other. So let me show you how to first calculate this with Python and then how to plot it. So I'll return to vectors I, P, Y, and B. And let me talk about the magnitude, by the way. So that's this term here in the denominator. To calculate the magnitude is to square all the components of the vector, add them all up, and then take the square root of the sum. So we will get something that looks like this. We will first add up all the components of the vector. So let's say the vector has components A, B, C. Then we will have A squared. Again, we have an arrow over the A, okay? So these two are distinct. Arrow over A means vector. This is component of that vector. A squared plus B squared plus C squared. If, for example, this is over R3. And then we take the square root of this sum. We're taking the magnitude for both vectors. So how do we calculate this in Python? Here, let me close this. What I'm doing here is enumerating over all the components in the vector V. So V is a vector. And we denote X. Let me put X sub I, just to make it especially clear. X sub I is a component in V, in the vector V. I'm going to import the math library. I will take every X sub I of V and raise it to the power 2. So this is the power method. X sub I is the base, 2 is the power, just like we saw earlier. This will give us a list. X sub 1 squared, X sub 2 squared, X sub 3 squared, and then we will use the sum function that's built into Python to add up all the elements in this set. Once we have the sum, we'll take the square root. And that's, of course, how you calculate the magnitude. To calculate cosine similarity of two vectors, we do this. Okay, this function will take two arguments, two vectors. First, we have the numerator. So we multiply these two vectors together. And then the denominator, which is the product of their magnitude. And then the return value, of course, is the fraction. I'm going to go cosine similarity of word vector 1 and word vector 2. If I run this, it tells me it's undefined. Let me run this again. Run that. We get, well, it's almost 1. Let's look at the cosine similarity of word 1 and word 3. I can see it's a smaller number. So they are not relevant. What about word 2 and word 3? Yeah, still not as high as these two. Now these are angles. How do we plot these angles on a plot like that one? So how can we visualize this?